All right, we did rational equations the other day. So now looking at rational graphs, there are these different things called asymptotes. They have horizontal and vertical. They have slant. We don't probably do that much with slant in this class. That's a pre-calculus idea. But the asymptotes are kind of like, what do you say? Like borders of the graph. So I know that they never cross a vertical asymptote. They can, I'll put rarely, cross a horizontal asymptote, but they usually don't. So what happens here is this graph is it comes up, the dotted lines are the asymptotes, and the graphs are going to get really, really close to the asymptotes, but never really touch it. So like this, you see this dotted line on the horizontal, it's going to get really, 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 really close to that, but it never actually touches it. So as this one goes down, it's going to get really, 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 really close to that vertical asymptote, but never touch it. The way a vertical asymptote is found is, so a vertical asymptote, you are going to set the denominator equal to 0. And when you set the denominator equal to 0, that's the one number that x can't be. That's why it will never cross that, because that's the number that x can't be. So your vertical asymptote is the numbers that x can't be. And we'll talk about horizontal when we get to it, because it's a little trickier. But what is it? Okay. The x and y intercepts are going to be the same as they always are. Where does it cross the x-axis? It actually, this one does not cross the x-axis, because the horizontal asymptote's there, so it's going to go close to it, but it's never actually going to touch it. The y-intercepts are going to be right here at -4. Write the equation for all vertical and horizontal asymptotes. So these are equations. These are vertical or horizontal lines. So remember, a vertical line is x equals a number, and a horizontal line is y equals a number. I guess I'll write that up here. This is always x equals a number, and this one's always y equals a number for the horizontal. So for my vertical asymptote, the x is right here at -3, so it's x equals -3. And my horizontal, which happens a lot, is y equals 0. Okay. So you do have to write x equal and y equal because it is a vertical and horizontal line. The domain and range. Domain, remember, same as before. This is your x values, and it's how far left to right the graph goes. And then your range is your y values. It's how far down to up the graph goes. Okay. So for my domain, this goes forever to the left. And then it goes up into -3. It doesn't actually touch -3, right? It's never going to touch my vertical asymptote. And then the other side, you use OR for that. It starts at -3 because, again, this side's going to get close to -3, but it's never going to touch it, so it can't equal, so you use parentheses. And it goes on forever. Forever to the right. And then the bottom of this graph looks like it goes down forever, but it does stop at 0. It never goes above 0. And again, it's going to be a parentheses because it does not equal 0. It never touches 0. So you use a parentheses and not a bracket. All right, so the rational functions, when you have an x in the denominator, sorry, I'm going to click explanation right here because I do not want to get my horizontal chart mixed up here. Less than is equal, greater than is none. All right, let me go do this real quick. So I said we're going to do this in a second. So vertical asymptotes are the easier ones because we've done this all along. Vertical asymptotes, you set the denominator equal to 0. It's the number that x can't be because you can't divide by 0. Okay. The horizontal asymptotes are trickier. For the horizontal asymptotes, you look at the degree degree of the numerator and the denominator. Okay. If the degree of the numerator is less than the degree of the denominator, which just happens most of the time, this is called a proper rational function. Then the horizontal asymptote is y equals 0. And we will, when we get to the test review next week, we'll make sure if we need to make a little chart. I don't expect you all to memorize this. If we can put it on the test work page, make a little cheat sheet or something, that's fine. This one, the degree of when they are equal is the hard one. So I'm going to skip that for just a second. When the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. There isn't one, okay? When they're equal, what you do, you take the coefficient, I guess it's the leading coefficient. So let me write the word leading there. The leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay. That sounds way harder than it is. It's pretty easy once we get to it, and we'll try to find an example that does that. But you have those different scenarios. So you compare the exponents of the top and the bottom. If they're less than, then the answer is y equals 0. If they're equal, then you look at the number in front of the top and the bottom and divide it. And then if it's greater than, if the numerator is greater than the denominators, there is no horizontal asymptote. So we'll do a bunch of these. So this one. So all you have to do on this one, you do not have to graph the entire thing. You only have to graph the asymptotes, because the asymptotes kind of are like our guidelines of where the graph is going to go. So it makes it easy. So my vertical asymptote here, you just set the denominator equal to 0. Subtract 2, divide by -1. So if I plugged in a 2 there, I'd get a 0 in the denominator. I cannot have that. So my vertical asymptote, it's positive 2, is at x equals 2. Okay. My horizontal one. So for the horizontal asymptote, the degree of the numerator is 0, right? There is no x. The degree of the denominator is 1. So the numerator is less than the denominator. So when it's less than, it's always y equals 0. So I just graph it at y equals 0. Now again, this tells me what my graph is going to look like. All of these graphs should have some kind of shape like this, okay? So they kind of follow your asymptotes. And that's what that one would be right there. Okay, let's refresh that and see if we can get a different problem here. Oh, you know what? These are all going to be like that. Those aren't going to change. They'll all have that same shape. Let's try this one. Yeah, I think this is the way this topic is set up. So on that topic, I think all the horizontal asymptotes will be y equals 0. On this one, my vertical asymptote, again, you set the denominator equal to 0. So subtract or add 2, divide by 4. 2 over 4 is the same thing as 1/2. So I think Alex makes it easy on you to graph the 1/2. But if I plugged in a 1/2, I would get a 0 in the denominator, which you can't have. Okay. Now the horizontal asymptote here, my degree of the numerator is 1, right? Because the x has the power to 1. And the degree of the denominator is also 1. So 1 is equal to 1 here. So what you do is you look at the front numbers. You just do y equals right here. Y equals negative 6 over 4. That's what I mean by you take the leading coefficient of the front one divided by the leading coefficient of the bottom one, which you can reduce that down to negative 3 halves. So that'd be negative 1.5. So it would be right here at negative 1.5. So on this topic, you're going to have to do, I think all of them will be equal. So you will have to do that where you take the front number. I'll do another one just to make sure we got it. Wait. That's this topic. So here my vertical asymptote, negative x minus 5 equals 0. Set the denominator equals 0. Add 5 to both sides. Divide by negative 1. So my vertical asymptote is x equals negative 5. It does always have a dashed line. I didn't really look at the Alex tools. Yeah, you got the dashed line right there. Horizontal asymptote. The degree of the numerator is 1. The degree of the denominator is also 1. So they are equal. When they are equal, you look at the front number. The numbers out in front here are 1 and negative 1. So it is y equals negative 1 would be my horizontal asymptote. Okay. So that chart's kind of hard to remember. If the numerator, you saw me look it up before I got started just to make sure I didn't mix it up. But if the degree of the numerator is less than the degree of the denominator, it's y equals 0. If the degree of the numerator is equal to the degree of the denominator, then you divide the number out in front of the top divided by the number out in front of the bottom. And then if the degree is, the numerator is greater than, then there is no horizontal asymptote. I believe the way I have built these topics though, that first topic is all going to be y equals 0. And then the next topic is going to be where you actually have to divide it out. Sorry. Let me say that again. The first topic, this linear over linear one, will always be where the degree of the numerator is less than the degree of the denominator. So the answer for the horizontal is going to be y equals 0. The next topic, is, where'd it go? No, I'm sorry. Sorry. Did I mess it up? I'm sorry. Constant over linear will always be where the degree of the numerator is less than the degree of the denominator, so it's y equals 0. Linear over linear will always be where the degrees are equal, okay? So that's where you have to divide the front number. So I believe as you're working through these topics, you only have to do like one. You don't really have to remember that chart. You'll just know that, okay, this topic's all going to be y equals 0. The next topic, you divide the front number. Oh, we got one more, though. Maybe this is the third one, the third way of doing it. So quadratic in the numerator or denominator. This one might mix them up a little bit, and you might get both. Okay, so you get to do each individually, and then they might mix them together. All right. Yeah, that's fine. The vertical asymptote is 2x squared plus 9 equals 0. You set the denominator equals 0. When I subtract 9, then divide by 2, you get x squared equals that, and to solve that, you do the square root. We can refresh over some complex numbers here. When you do the square root inside the equation, you get plus or minus. You do the square, well, the square root of a negative is going to have an I on it, right? Because it's the square root of a negative. So this is an imaginary number. This means there is no vertical asymptote. There is no vertical asymptote because I got an imaginary number and we're not graphing imaginary numbers. Not yet anyways. All right, so there is no vertical asymptote. The horizontal asymptote, the degree of the numerator is 2. The degree of the denominator is 2. Y'all are good on like finding the degree, right? That's just the highest exponent. Okay. So I am going to take the front numbers as my horizontal asymptote. So 3 over 2. So that would be 1/2. So my horizontal asymptote is at y equals 3 over 2. I believe this one may mix them up. So like that one, the degrees were equal. And that one, they'll be equal. That one you got to factor. So this one right here, when I do my vertical asymptote, set the denominator equal to 0. You may have to factor on these. I can divide everything in here by 2 to start. So that becomes 3x plus 2 equals 0. So x plus what multiplies to be 2 and adds up to be 3. 2 and 1, right? 2 plus 1 is 3. 2 times 1 is 2. So my two answers here are -2 and -1. On this one, I have 2 vertical asymptotes. So that is fine. You can have 2 vertical asymptotes. And now my horizontal asymptotes, my degree of the numerator is 0 because there's no x's. My degree of the denominator is 2. So 0 is less than 2. That means you do y equals 0. So on this topic, you may get all 3 scenarios. So I'll go back to that chart for just a second if you want to take a picture of it or whatever. And again, on the test, we'll see if that one pops up on the test. If not, pops up on the test, I'll give you that chart. If it doesn't, then we'll do that. So if the degree of the numerator is less than the degree of the denominator, it's y equals 0. If they're equal, you divide the numbers in front, and if it's greater, there's no horizontal asymptote. We haven't done one with no horizontal asymptote. Here's one with no horizontal asymptote. I won't work it out because I've done a bunch of these, but the degree of the top is 2, the degree of the bottom is 1, so the numerator is greater than the denominator. This would have no horizontal asymptote. This one wouldn't have one. All right, now we get to go to fully graphing them. Actually, do I want to do this one first? Let me look at this one. Yeah, let's do the transforming first. Okay, so they do have transformations just like they had on the last test. So below is a graph of 1 over x squared. So what happens if I add 1 on the inside? So this is on the inside right here. I'd consider this on the inside. If it was on the outside, it'd look like this. So remember, on the inside, it's left and right. And you do the opposite of what it says. This is +1. So that looks, you think you'd go to the right, but it's actually to the left 1. And then you have the negative out in front. Remember, a negative out in front does something up and down. Flips it, well, we'll put the correct math words here on this one. Reflects up and down, so that'd be across the x-axis, okay? So the first thing I do is reflect it up and down to where it looks like this. And then I'm going to move it to the left 1. If you look, all these points, I didn't do a very good job of drawing this one, but if you look, all these graphs that we've done go through the point 1, 0. So when I reflect that down, it should be at -1, 0. I didn't do a good job of drawing either of those, because that one should go through there. You don't have to draw these out because you can use the tools. We'll use the tools in just a second. So to move it to the left 1, I can just take that point right there and move it to the left 1. So my graph is going to look, I know I'm drawing stuff on top of stuff, but I moved the red one would be my answer. Okay. So you reflect it, and then you move it across 1. It's a lot easier to do that on the computer. You just have to know the steps of which way to move it. But the transformations work the same way as what we've been doing in the other ones. The absolute value, it doesn't matter which one they are. So here's one. The x plus 4, we're going to consider that on the inside because that is in the denominator, right? So I'm going to move it to the left 4. So first thing I'm going to do is move it to the left 4. And then the minus 3 is on the outside. That's on, you move it up and down. It's minus 3, so I move it down 3. Okay? So I moved it to the left 4, down 3. I don't think they get into very tricky ones on these, so that should be about all the different ones you see. This would be left 4, and this would be down 3. So we went left 4, down 3. I'll refresh a couple more to see if it gets any trickier, but I don't think it does. Done that one, done that one. Oh, it does have a 2 on top. Okay, so this one starts with the graph of 1 over x, and then we have a 2 on top. The 2 on top is like multiplying it by 2 on the outside, so that is going to vertically stretch it. So I'm going to stretch it. Instead of being at 1, it's going to be at 2 because 1 times 2 is 2. And then that 1 on the inside, I'm going to move it to the right 1. Do y'all remember those transformations a little bit? We might use them one more time throughout this class, so like they don't go away, because any graph, it doesn't matter what we do, square root, squared, absolute value, x cubed, these rational ones, they all same thing. If you add or subtract something, it shifts it left, right, up, down. If you multiply something, it stretches it or compresses it. So they all do work right here. So this minus 1 right here would be the right 1. This 2 right here is going to vertically stretch it. Okay. To be on the inside of a rational, it would be something's happening down here to the x. So it's kind of like on these, the inside is the denominator and the outside is the numerator. All right, the last ones in this section are actually graphing them. So how do I graph them? The first thing I do, and this is why you have to take a math class. I know I've said this before. When I go to graph this, I have no idea how to graph this, right? I don't know how to graph this, but I know how to find the x and y intercepts. Okay, to find the x-intercept, you make y be 0. To find the y-intercept, you make x be 0. We just talked about how to do the asymptotes. We know how to do what the shifts kind of look like. So, like, you just start putting these small pieces together, and you can solve a bigger problem. And, like, those critical thinking skills are why you have to take math. So it says start by drawing the vertical and horizontal asymptotes. So my vertical asymptote, you set the denominator equal to 0. Y. Well, let me write right there. So subtract 2, divide by negative 1, so x is equal to 2. So my horizontal asymptote, my vertical asymptote is at x equals 2. My horizontal asymptote is, the degree of the numerator is 0. The degree of the denominator is 1. 0 is less than 1, so it's y equals 0. This is another topic that they're all going to be y equals 0 on because it's a constant over a linear. Okay. All right. So my graph has 4 options. It's going to look like, I'm using yellow here, I know it might be hard to see. It's going to look like this, or this. Okay. It's going to be probably 2 of those 4 options. So now what I have to do, and it tells you in the directions, start by drawing the vertical asymptotes, vertical and horizontal asymptotes, then plant 2 points on each part of the graph. So what you need to do is plug in 2 points to the right of the vertical asymptote and 2 points to the left, okay? So base everything on that vertical asymptote. So I'm going to plug in x equals 3 and x equals 5 for the right side. Actually, I'll put this on the right side here. What did I do? All right, so this is the right side of x equals 2. I'll put vertical asymptote, actually. The right side of the vertical asymptote. X equals 3, if I plug that in, -2, -3 plus 2, -3 plus 2 on the bottom, -2 divided by -1 would be +1. If I plug in a 5, -5 plus 2 is -2 over -3, so 2/3. So I have a graph at 3, 3, 1, and at 5, 2/3. My goodness, every time I click. 5 and 2/3, okay? All I'm really trying to decide, I'm plugging a number in on the right side of the asymptote. So all I'm really trying to decide is my graph going to be up here or is it going to be down here? And obviously, both my points are up here, so my graph is going to be above the blue line, okay? So you pick a point on the right, there are 2 points on the right side and 2 points on the left side, and then you're trying to determine, based on those points, are you going to be above the blue line or below the blue line? And now find the left side of the vertical asymptote. So I got to pick any numbers over here. Zeros on that side. That's always to plug in, easy to plug in. And let's plug in -1 too. -2, -0 plus 2 would be -2 over 2 would be -1. So 0, -1 would be right here. So it looks like I'm below the blue line. We can double check that with another point. -1 would be +1, so this would be -2 over 3. So at -1, I'm at -2/3. So it is going to be below the blue line. Okay? So that kind of makes sense. You pick 2 points on the right side of the red line, and then you're trying to figure out if you're above or below the blue line. You pick 2 points on the left side of the blue line, and you're trying to figure out if you're above or below the blue line. Okay? Now this is even easier on Alex because let's see if I can do this fast on Alex since we already did these. On Alex, it's going to make me an inner coordinate? What was it? 0 equals negative, no, it's +2, wasn't it? Oh, so it would be 2, 0. So for my vertical asymptotes, it's 2, 0. For my horizontal asymptote, it was at 0, 0, right? I don't know if I've seen that before. All right, so then I pick a point. To plot a point anywhere, we plugged in x equals 3, and we got out 1. All right, I think that's right. And then we plugged in 5. You can plug in any number you want to, and we got out 2/3. Okay, and then we plugged in. So all you got to do is type these in. So it doesn't matter if you get a fraction for your answer. 0, I believe, was -1. And then we plugged in a -1 and got out a -2/3. Okay. Oh, no, my 0, the other one didn't graph. 0, -1 didn't get plotted. Okay, so that tells me my points. And then all I do is click the... No. Why did it do that? That's not right. Did I type a point in wrong? When I plugged in a -1, what did I get out? That's where I got negative 2/3. Isn't that what I did? And when I plugged in a 0, I got out 1. No, I got out negative 1. No. What did I do wrong? Did I do some math wrong here? I don't see anything I did wrong. When they plugged in a 3, they got a 2 out. Oh, yeah. There's my mistake. That right there is wrong. That should be negative 2 divided by negative 1 is positive 2. That messed it up. My bad. It's hard to do math. Y'all know, right? So, don't make simple mistakes. So when I plugged in a 3, I was supposed to get out, what, y equals 2. That probably messed it up. All right, we still had the gist. We still had the right graph. We just had the wrong thing there. All right, to do the other one, it's going to be very, very similar to what we were doing there. The difference on this one is you're going to have, let's see if we can just do it on the computer. Y'all might have to help me plug in some stuff. My vertical asymptote. What number can I not plug in? What number would give me 0 in the denominator? Can y'all look at it and tell? 2, right? If I plugged in a 2, it would be negative 2 plus 2 would be 0. So that would be 2, 0. The horizontal asymptote. You got an x on top, so my degree is 1. You got an x on the bottom, so the degree is 1. So the degrees are equal. So my horizontal asymptote is going to be negative 2 divided by negative 1. Negative 2 divided by negative 2 is positive 2, correct? I just made a simple mistake. Now we're trying to do it all in our head. That's about right. 0, 2. Okay, so now we have to plug in points. Our points that we're going to plug in are on the left side of that vertical asymptote and the right side of the vertical asymptote. So we'll start on the left side. If I plug in x equals 0, that all goes away, so I get 1/2, right? So 0, 1/2 should be a point. I plugged in x equals 0, I got 1/2 out. What?
Oh, it's a plus sign, never mind, sorry.
Okay, now let's plug in a 1. If I plug in a 1 to this problem, on the top, negative 2 times 1 is negative 2. Negative 2 plus 1 would be negative 1. On the bottom, when I plug in a 1, negative 1 plus 2 would be 1. So negative 1 over 1. Y'all good? Like, am I doing it right? Do I need to write this all down? This is the way y'all try to do it in your head anyways, right? Because y'all don't want to write stuff down. 1 and negative 1. That looks good to me. Like that, it kind of looks like it makes that arc. Okay. All right, now let's plug in numbers on the right side. If I plug in a 3, negative 2 times 3 is negative 6. Negative 6 plus 1 is negative 5. When I plug a 3 into the bottom, negative 3 plus 2 would be negative 1. So negative 5 divided by negative 1 would be 3, 5, right? Y'all with me at all?
Yes, sir.
Okay. If I plug in a 4, negative 2 times 4 would be negative 8. Negative 8 plus 1 would be negative 7. So I got negative 7 on the top here. I plugged in a 4 on the bottom. Negative 4 plus 2 would be negative 2. So it should be positive 7/2. Oh, no, it didn't plot my other one. What was my other one? When I plugged in a 3, I got out a positive 5, wasn't it? Forgot to click plot. So let's see. Haha, we got that one to work. So I knew the last one was wrong because it gave me all the squiggly lines, right? But again, what you're doing is you're plugging a number in the right, and you're trying to figure out if it's above or below the horizontal one. You plug a number into the left, and you're trying to figure out if it's above or below. They always will have that shape to it. Okay. So you'll know kind of if you made a simple mistake, if you like get one above the horizontal asymptote and one below, or when you click that button, if it grabs a squiggly line like I did, I just made a simple mistake. I said 2 divided by 1 was 1 instead of 2. So this is the idea here. I just wanted to graph it on the computer, but I'll kind of write that out. So if anybody goes back and looks at this, they'll have the answer here. But yeah, that is the graphing rational function section. That is